Hello, everyone. I'm a professor of public health nutrition at the University of Washington. And you'd appreciate that some of the themes in human nutrition are the same as in pet nutrition. We're increasingly concerned with the environment and sustainability of the food supply. We're very concerned with urbanization. And of course, we're also looking at alternative protein sources. So my talk today will deal with the obesity challenge. What is the relation between nutrient density and obesity in humans? Notice I'm not talking about calories. The conventional approach to obesity is to talk about too many calories, too few calories. No, I want to talk about nutrient density of foods, meals, and the nutrient density of total and complete and balanced diets. There's an economic component to the obesity challenge. I should say both economic and social. And these are the challenges laid out for you on this slide. First of all, global diets have become increasingly energy-dense but nutrient-poor. We're drowning in empty calories. And there is an economic component to this because empty calories generally cost less and nutrient-rich foods can cost more. This is denied by some people, but it really is a fact. Eating healthy can cost you extra. So as a result, obesity and poverty are now linked. Obesity used to be the disease of affluence. It is now the exact opposite. In lower income nations, it is going to be the urban poor who are now increasingly becoming obese. We're now facing a dual burden of disease with obesity and undernutrition coexisting. And the action for public health is that we need a food supply and we need foods which are, at the same time, nutrient-rich, affordable, socially acceptable, and then sparing of natural resources in the environment. Are there such foods? Can they be available to all? That is the challenge. Because, of course, the food supply and health are correlated. So this is the key question posed very starkly. Is the global obesity epidemic caused by unbalanced diets and by cheap, empty calories of minimal nutritional value? And there's a great deal of evidence that this, in fact, is the case. But I want to build my argument by giving you three major concepts to work with. And again, I'm going away from calories to calories per unit volume. So not just calories, energy density of foods. I don't want to be looking at single nutrients. I want to be looking at nutrient density of foods, nutrients per calorie. And then the next concept is nutrient balance. Are the nutrients balanced within a food, within a meal, within the diet? And then underlying all of those is the notion of energy and nutrient costs. So keep those three themes in your mind: energy density, nutrient density, and nutrient balance, and the underlying issue of the cost of it all. And we can look at the monetary cost, meaning the cost in dollars, pounds, euros, or we can look at the environmental cost. The environmental cost, of course, is going to be the cost in land use, water use, and energy use, greenhouse gas emissions, the shrinking water resources, this kind of thing. But let's go back to this very key notion of energy density. And this is where the economics come together. It was a dogma in nutritional epidemiology that the more food you ate, the more nutrients you got. So you eat more food, you eat more calories, you get more nutrients, the two go together. And in fact, nutritional epidemiology always used to adjust for total calories to take calories out of the equation and deal with the nutrients. But this is no longer true because this dogma, this kind of connection between calories and nutrients was uncoupled by the very low cost of empty calories. Some calories just do not carry the necessary nutrient load. I like to think in terms of nutrient to calorie ratio. Some foods will have more calories than nutrients, and other foods will have more nutrients than calories. That is the whole point of nutrient density and nutrient balance. So now it's actually possible to be overfed and yet undernourished. And this is where the concept of hidden hunger comes in. And this is because of cost, because these are what on this slide, there's a whole range of what I would call nutrient-rich foods, loaded with nutrients, with relatively few calories. And then you have, other foods where you have calories but relatively few nutrients, and those foods, let's face it, are cheaper. They taste good. People like them. It's a problem. So what is energy density? Energy density is measured in calories per 100 grams. Essentially, the range of energy density goes from tap water to oil. Tap water, 0 calories per gram. Oil, 9 calories per gram. Sugar, protein, right in the middle, 4 calories per gram. And it actually is water that determines energy density of foods. You may think that energy-dense foods are full of sugar or fat. Sometimes they are, but it's really water, because water gives foods bulk and volume, but no calories and no nutrients. So the energy density really is water, and energy-dense foods are dry. So when you look at this kind of relation, on the vertical axis, you have the water content of foods. On the horizontal axis, you see mean energy density for various food groups, and you see the water content and the energy density are inversely linked. Vegetables and fruit have about 80% water on the average, whereas grains and fats and oils have no water. Grains are dry. So this is the basic relation, energy density, water content. The data are from the United States Department of Agriculture Foods Composition database for about 1,400 foods. So this is the relation. And in fact, there are 2 components to this. First of all, high energy density may cause overeating. There are a number of papers, articles, books based on the volumetrics principle. The same number of calories can be presented to you in different ways. The second slide on the bottom right is from my friend and colleague Barbara Rawls's work, and she shows that you can pack close to 1,600 calories into a very tight package, very small volume, or you can present the same number of calories at a much higher volume, and Barbara's point is that greater volume prevents overeating, allows you to better manage portion size, and stops you from over-consuming extra calories, because in a small volume, this stuff kind of slides right in without any satiety being triggered. There's another component to this. Satiety is one, but the second one is, of course, cost. This is a phrase, this is kind of passage from a publication about cabbage and the cost of cabbage. We're really looking at the cost of food. What is good value, what is bad value, what is cheap, what is expensive. I'm showing this because I've had this argument with the Economic Research Service of the USDA. They said vegetables are cheap provided that you measure them per pound. So this passage is, cabbage at 2.5 cents per pound seems cheap, but 10 cents worth of cabbage furnishes 500 calories of energy. Cabbage is low energy density. While 10 cents worth of wheat flour at 3 cents a pound furnishes more than 5,000 calories and is truly cheap. Any guesses when this passage was written about cabbage and wheat? The publication on the left is from, I think, 2014 from USDA. But I had to go into USDA archives, back to USDA, because they wrote about it before, but they wrote about it in 1902. So this notion of cheap, expensive, calories, pounds was actually raised and answered in 1902. So these are kind of latest data, but they're not that new. So yes, it's true, vegetables will cost less per 100 grams. Here you have mean water content and the cost per 100 grams. The cost is from the National Food Prices database that also USDA published a while back. And notice that grains, fats, are cheaper per 100 grams. Meat, poultry, fish, vegetables, and fruit are more expensive per 100 grams. The moment you start looking at calories, everything changes around. So here now you have mean cost per 100 calories, again, mean water content, and then as you see, you go from dry grains and fats and oils and sugars towards the milk products, poultry, fish, vegetables, and so on. Water content goes up, cost per 100 calories goes up. So I always say the most expensive ingredient in any food is actually water. Because for fresh foods, you have to have a cold chain, you have to have preservation, you have to have refrigeration, you have to have issues with distribution, it's perishable, it is expensive. Dry foods are cheap. So grains, fats, oils, cheapest things, meat, poultry, fish, vegetables, more expensive. The problem in public health is that the advice that we give to the public is eat less of grains, fats, and oils, and please, please eat more fruits and vegetables than meat, poultry, and fish, and make sure that the vegetables are not only fresh, but organic. And I say, yeah, but bring money. So this is the problem, however, because the low-cost energy-dense foods of high nutrient density can be more expensive. No, the low-cost energy-dense foods can be nutrient-poor, and the nutrient-rich foods are more expensive. So notice here, we have got energy density on the vertical axis, mean cost per 100 calories on the horizontal axis, and as you see here, high energy density, cheaper, low energy density, but more nutrient-rich, more expensive. So for $1, and this is interesting, this was in Michael Pollan's book, for $1 you can buy about 170 calories of fruit or 1,200 calories of potato chips. What is your choice if you have no money? So next concept, how do we then measure nutrient density, and how do we measure nutritional value per unit cost? Because now we are moving from energy density, cheap calories, to nutrient density. What are foods which give you best nutritional value per penny? What are those foods? So here we have to go into another methodology, and that is nutrient profiling. So the nutrient profiling methods rate foods based on their nutrient content relative to calories, and we can measure also nutrients per dollar or per pound or per euro. The question, of course, becomes which nutrients, how many of them, what is the standard unit amount? Are we measuring nutrients per calorie, per serving, per 100 grams? What is the method that we want to use here? So nutrient profiling is actually a very useful technique, and you'll be familiar with it because nutrient profiling provides the underlying scientific basis for many of the health and nutrition claims and also for front-of-pack logos. And there are a number of those. What I'm showing you here is two types of nutrition labeling. On the left, you have nutrient by nutrient guideline daily amounts with specific nutrients, especially bad nutrients. I'm using the word advisedly. I don't like to talk about good or bad nutrients, are being singled out. And on the right, you have an overall symbol or logo for the total nutritional value of the food product. And you've seen those, the checks, the My Choices, the Great For You, the guiding stars. All of those things have been used in supermarkets to try and guide consumers towards the healthier, better for you options. And nutrient profiling is the underlying scientific base for it all. So when we create nutrient profile models, what I'd like to do is to follow the guidelines established by the European Food Safety Authority. You've got to make some decisions about profiling the nutrient value of a given food. You need to decide whether or not you want to apply the same criteria to the entire food supply, or do you want to do it per food category. You've got to decide what are the good nutrients. The European Union called them qualifying nutrients because foods with a good profile qualified for nutrition and health claims, and foods with a bad profile were disqualified from nutrition and health claims. So you can talk about those as qualifying and disqualifying nutrients, or in terms of dietary advice, you can talk about them in terms of nutrients to encourage versus nutrients to limit. As I say, I try to avoid the idea of good and bad, but these are the nutrients that we use. On the green side, there is going to be protein, fiber, vitamins, minerals. On the bottom, you have fat, saturated fat, added sugars or free sugars, and sodium. And the nutrient-rich foods profile is a nutrient profiling system that takes 9 qualifying nutrients, percent daily values, 3 disqualifying nutrients. It's calculated as the sum of percent daily values for the positive nutrients minus the sum of percent daily values for the negative nutrients. It's very arithmetically simple. There are other models, FSA Ofcom in the UK, the Saint-Lim in France, and other methods similar to this that also use combination of nutrients. So this is the nutrient-rich food index, and this is how things look for individual foods. Again, you're probably thinking by now that it really isn't the individual foods, it's the diets we should be looking at. But stay with me, we'll talk about individual foods first. This is how things look. So here we have, for example, vegetables. What you see on the horizontal axis is the nutrient density per 100 calories. On the vertical axis, you see energy density. Obviously, French fries are more energy dense with all this fat than are fresh vegetables and salad greens. Salad greens are kind of off the scale because the energy density is so low. So they kind of runaway spinach because energy density of spinach is only 10 calories per 100 grams. So the ratio of nutrients to energy density is going to be extremely high. So we actually cap it. There's some mathematical things that go into profiling. So notice here, these are the vegetables and the fruit. Dried fruit, canned fruit, lower nutrient score because of the added sugar and sugar syrup. Here we're moving towards our grains, fortified cereals to the right, but cakes and cookies and so on to the left, saturated fat and sugar. Here we have dairy products, skim milk, low-fat yogurt to the right, ice cream to the left. Here we have nuts, high energy density, but good nutritional value, eggs, fish, seafood, beans, and so on. Here are the fats. Here are the sugars, all the way to the left. So in fact, the entire range goes pretty much from soda or sugar to spinach. And again, notice that it's a continuum. There is no line saying good foods to the right, bad foods to the left. There is a line here. No, it's a continuum. And within each food group, there is a range of possibilities in terms of both nutrient density and cost. So people can select within each food group the foods which are most nutrient dense for them at the appropriate price point and the appropriate value. So this is the nutrient density of close to 1,400 foods showing the various food groups and the range from not so good to much better. And of course, again, going to the cost issue, if you plot it against energy cost, you will see that the nutrient-rich foods do, in fact, cost more per calorie. There are plenty of good foods in the middle, but if you go all the way to the left, you see it's mostly going to be sugar and grains, although some very nutrient-rich foods such as beans and alternative protein sources are also mixed in because beans and eggs actually are fairly inexpensive in the US food supply. So not every nutritious food needs to be expensive. So just to go back to the importance of nutrient profiling, so pay attention to that when you go back. It has become the global scientific basis for nutrition and health claims, front-of-pack labels, taxation. I'll talk more about that a bit. And then marketing and advertising to children in the UK, and then, of course, reformulating product portfolios. Companies are increasingly using nutrient profiling to look at their product portfolio, saying, maybe these pizzas are a bit too high in sodium. Perhaps you should take some of this sodium out based on nutrient profiling of our pizzas and the competition pizzas. So this is being used for a number of purposes, from regulatory to reformulation. So I'll show you how we apply this nutrient profiling technique to different cultures. So different continents, it can be also applied cross-species. It's the same principle. So the nutrient-rich foods here was developed for Turkey. I developed a short algorithm for Turkey, looking at nutrient of public health concern in Turkey, and this had to do with pediatrics and snacks allowed by the Ministry of Education for sale in Turkish schools. Again, this is what they came up with. Notice that the range going from left to right is pretty much what I have been talking about. You have the fresh produce on the right, you have the emptier calories on the left, and all kinds of foods in the middle. Actually, for children, I don't think children will be taking snacks of cucumbers, so it's really the foods in the middle which are of greatest interest. So these are the snacks for health in Turkey. Again, nutrient profiling, going from less nutritious to more nutritious, nutrients per calorie. And then these are the foods and beverages which should be supported in Turkey. And again, this was nutrient profiling. They are now putting in little smiling on frowning faces. So this is a kind of not a traffic light system. It's a kind of crying face system. And again, this is not that different from what the National Cancer Institute had come up with in dividing foods in children's diet into what they call the go foods, the slow foods, and the woe foods, based on energy density and the nutrient content, especially the content of fat and sugar. So again, nutrient profiling of some sort is the underlying basis for all of these things. We are applying some of these things now to Mexico. The Mexico case is very interesting in public health because of the taxation on energy-dense foods and sodas. Now, people forget that Mexico did not just tax sweetened sodas. They also taxed what they called non-essential snacks of energy density greater than 275 calories per 100 grams. So in fact, they were taxing foods that were dry. So I developed a preliminary naturally nutrient-rich score for Mexico based on protein, fiber, calcium, iron, vitamin C, vitamin D, and potassium, again, nutrients of concern in the American diet. This is the nutrient density of foods from Mexico using national nutrient composition databases and prices from the Mexican Economics Institute. Notice that the nutrient density is pretty much the same what we had with NRF 9.3. So it goes from soda to spinach. We have butter and fat and sweets and dried fruit and potatoes and peanuts and cheese and beans. Same nutrient density. And interestingly enough, the same price hierarchy. People are always convinced that in Mexico, avocados grow on trees. Well, they may grow on trees, but they're kind of more expensive. What's less expensive is lard. So here you see that you have the lowest cost sources of energy in Mexico will be lard and corn and more lard and fried potatoes and sweet cookies and fried beans and chocolate and cereal and then milk and soda. And Mexico is having an obesity epidemic. And again, this is very much to do with the low cost of empty calories and with the higher cost of leafy green vegetables, strawberries, tomatoes, lettuce, and so on. Paradoxically, of course, much of the fresh produce in the US actually does come from Mexico. So yes, it's grown there, but it's grown for export, and people eat lard. So this is a problem that we have because then issues of economics and trade and so on all come into it. So then when you start looking at the energy cost, you see the same thing as we have seen before. Poultry, fish, seafood, meat, fresh vegetables in Mexico follow the same price hierarchy as everywhere else. And what is cheap is sugar and cereal and lard and rice and beans. And that, in fact, is the diet of the Mexican poor. And in fact, yes, obesity is increasingly spreading in Mexico now among the poor. It used to be the preserve of the rich. No longer. It is now spreading among the Mexican poor. And again, in Mexico, nutrient-dense foods cost more per 100 calories. So the issue of regulatory uses of nutrient profiling becomes very interesting and important in public health. because Mexico has imposed this tax on non-essential snack foods. I actually presented before the Mexican Ministry of Health a couple of years ago, and I said, well, the sodas and the snack foods are not the major sources of calories. It really is tortillas and lard. And they said, well, we couldn't possibly tax those. It's cultural. So again, some of the taxes are based on science, but some of the taxes are not really based on science. So the United Kingdom has a tax based on sugar content of beverages. British children do consume a lot of sweetened soft drinks with their meals. The French children seem to be consuming more water. Chile is proposing to impose a tax based on nutrient profiling of foods. And of course, as I mentioned before, Turkey has ranked foods based on their nutritional value for sale in schools. So these issues now start moving from economics into regulatory issues and taxation and public policy. So this kind of interesting transformation of science to public policy, to economic policy, and to the global nutrition policy, because now WHO is releasing its own nutrient profiling system. So this is Mexican tax, as you see here, is based on energy density. That's why it's important to keep the concept in mind of energy density so that you know which foods are potentially going to be taxed in different jurisdictions. And notice that the sugar, the cereals, the desserts, the ready-to-eat cereals, and of course the oils are all in excess of 275 calories per 100 grams. And of course, again, the more nutrient-rich foods are generally lower in energy density and fall below the 275 calorie threshold. Now, nutrient balance. Again, I'm sure that you're thinking that the nutrient density of foods does not really reflect the nutrient quality of the diet. And in fact, Helen Guthrie a long time ago used to say that there are no good or bad foods, there are only good or bad diets. But it's still true. She was saying this 40 years ago. It is exactly correct. It was the consumers and the regulatory agencies that wanted to do nutrient profiling of individual foods to show which foods were more nutrient-rich than others. But now we come to this notion of nutrient balance, because some of the very high-scoring foods on the nutrient profiling scale have one single nutrient. They have extraordinary amounts of that nutrient, but that's all they got. Green peppers have phenomenal amounts of vitamin C. But pretty much, that's it. So what do we do? And how should we be combining the foods into meals to make meals nutrient-dense? And there is some new research about nutrient balance published. And I'll just kind of walk you through it very quickly, because what we did here was to look at, again, the relation of the qualifying nutrients, horizontal axis, and the disqualifying nutrients, the vertical axis. So on the horizontal axis, you have the nutrient density score effectively, because it goes all the way from sodas to leafy vegetables, spinach. It's the same soda, sugar to spinach continuum on the horizontal axis. See this? We're going from candy and sodas and savory snacks and cereals and potatoes and fruit and then breakfast cereals and vegetables, spinach. On the vertical one, we go from low energy density, sodas are low energy density, to fats and butters and so on. This is not quite energy density because cholesterol and sodium go into it. This is why eggs and soups score high. If you took out sodium and cholesterol, you'd have the energy density score. So these are the individual foods. But what happens when you put the foods into meals? What we did here was to look at the score, nutrient density score for individual foods, and to see how meals shaped up. What we did, we took My Plate meals. The United States Department of Agriculture that publishes My Plate published My Plate recipes for 2 weeks. And those recipes were pretty much designed by dietitians to be nutritious. So what we did here was to score them. So we expected the scores to be high, but we expected some differences. Maybe some of the meals created by USDA dietitians were in fact more balanced than other meals. So what you see here is if you look at breakfast, You got sugar and raisins and orange juice and fat-free milk and oatmeal, and each of those foods has got a score. Sugar has a low score, fat-free milk has a high score. But you put them all together in terms of the nutrient balance they provide, and you get a score of 8 to 1. This is the average score. Here you have something more complicated. This is now lunch. You see chips, oil, cheddar cheese, turkey, salsa, huge score because of all the vitamins and low energy density, lettuce, coffee, and this is your combined meal. So you actually can use this technique to look at the overall nutritional value of a meal. And we did this again with more My Plate meals and My Plate snacks to show that a meal of, say, whole wheat, chicken breast, coffee, sweet potato gave you a fairly high score over here, and a meal with more lettuce and celery actually was even higher, scoring 94 out of 100. So there are ways of applying the nutrient profile to look at nutrient density of meals and, by extension, nutrient density of the total diet. So we do need, in fact, complete and balanced diets. And there are ways, again, of applying the same techniques to evaluate the overall quality of the diet. We actually did that with the diets of French children, applying the nutrient density score for each age and gender group to find out what was the maximum score for each group. So one more concept in public health nutrition. The emphasis on dietary guidelines is increasingly shifting from individual nutrients to food patterns. There were suggestions of that in the Dietary Guidelines 2010. There was more of food patterns in the Dietary Guidelines 2015. I suspect the emphasis will be totally on food patterns in the Dietary Guidelines 2020. And this gets me back to a bit of a problem in nutritional epidemiology. Nutrition epidemiology, over the past 20 years, has focused on establishing the relation between a single nutrient and health outcomes. So all of you will have read papers in New England Journal of Medicine, out of Boston, Nurses' Health Study. We're linking vitamin A to this, vitamin B, vitamin C. It's alphabet of nutrients, all linked to some kind of a health outcome. And nutrition epidemiologists who've been saying we can link a single dietary ingredient, we can link a single food to a health outcome, have come under attack from the sociologists and the ethnographers who are increasingly saying you cannot separate the person from the food and you cannot separate the person from society. And this is why the new nutrition science is increasingly embracing sociology, economics, business, ethnography, anthropology. We're all saying, come on in, because all of this is part of the new nutrition science, and we really want to deal with the social and environmental and cultural aspects of food and the food supply. So we no longer think that one food is the problem, and if we take that one food away from the food supply, all will be well. Especially as you saw, eating of a given food or the consumption of a given food is so tangled up with economics and policy and politics and various other things, it is impossible to do. So for example, here in the dietary guidelines, we were told to eat more whole grains, more vegetables, more fruit, more whole fruit, not even fruit juice. And I'm saying, yes, but those are expensive foods. And if you go from, say, frozen orange juice to blackberries or blueberries at $7 a pound, you're really looking at a different social class and different types of expenditures. And yes, rich people eat better foods, they have better diets, and yes, they live longer. Is it because they ate blueberries, or is it because of all the other things that we do not observe? And I suspect it is because of the other things that we do not observe. In fact, we're finding increasingly in Seattle that the best predictor of diet quality is actually your address and the value of the home that you live in. look at our paper in Preventive Medicine published last year, we have a beautiful map of diet quality in Seattle by census block. It's like doing a map of England by postal code and predicting diet quality based on the tax value of homes. It is really that predicted by socioeconomic status. So here we have the advice to eat more of expensive foods, eat fewer of the cheaper foods, but the costs are really not taken into account. So this kind of gets me to this new interesting research on what we call nutrition resilience. Actually, it is possible to eat better for less. So here we go back to the USDA data. We look at nutrient composition. We look at dietary intakes. We look at prices. And we look at HEI. HEI is the Healthy Eating Index. HEI, the Healthy Eating Index, is designed to measure compliance with the dietary guidelines. So it's operationalized compliance with the dietary guidelines as assessed in the American population using food patterns. So HEI 2005 is Dietary Guidelines 2005. There is now HEI 2010, Compliance with Dietary Guidelines 2010. We don't yet have HEI 2015, but it's probably going to be coming out soon. USDA and the National Center for Health Statistics deal with this. So this is now an index of the quality of the total diet. And here notice that it's based on both foods and nutrients. So these are the foods and food groups to encourage: total fruit, but also whole fruit; total vegetables, but also green vegetables; whole grains and dairy and protein foods and seafood. So actually they're kind of picking out whole fruit and seafood, somewhat expensive foods. The HEI is actually tangled up with socioeconomic status. And then on the negative side, you have sodium and empty calories, or SOFAs, solid fat, alcohol, added sugars, and then refined grains and saturated fats. So this is a 100-point scale determining compliance with the American diet. The average score in the US is about 54 out of 100. Good diet is 85 plus. Diets that need work, 33 points out of 100 to about 85, and below that is what they call a bad diet. But notice that the more you spend, the better you eat. So this is now a split of diet quality scores by quintiles of cost. And we go from cheap diets on the left to more expensive diets on the right. These are data for women. The higher the point score, the better the diet is. So if the point score for sodium is higher, that means you eat less sodium. If the point score for fruit or vegetables is higher, you eat more vegetables. So notice that as you go from cheaper diets to more expensive diets, yes, you are eating more total vegetables in blue at the bottom, more greens and beans, more total fruit, much more whole fruit, and then some of those things are neutral. Dairy, for example, does increase, but not that much. So some of those food groups are very cost sensitive and others are not. So we get this type of relation for women, and we get the same kind of relation for men. It's the same thing. So what we're now finding is that there are some groups that seem to have a good diet at a lower cost, and we want to know who they are and what it is that they do. Because this notion of nutrition resilience means that you can have a complete and balanced diet for less. You can eat better for less. Who are the people who do that, and what it is that they do? We have some evidence that cooking at home actually could help. So this kind of brings me back to kind of my final considerations. We have been successful in linking food, health, and incomes. The phrase food, health, and incomes goes back to John Boyd Orr, 1936. I'm not the first person to deal with this issue. Of course, he got the Nobel Prize, but it's the same theme. So we're finding that if food budgets go down or the food prices go up, that's the blue inset, we find that people, of course, do not want to be hungry. So they gravitate towards foods which give you more calories per dollar. You have $2 to spend, and now you have $1.50, or you have $3 to spend, and now you have $2. You don't want to be hungry, you don't want to go short, so you're going to go towards foods which give you more calories for your dollar. More ramen noodles, more potato chips, more sugar, more fat, more donuts, and paradoxically, by spending less, you may end up eating more. That is the paradox. It used to be the case by not having any money, you ate less. No, it's actually reversed. And the cheap, empty calories are to some extent the culprit. And so where do we go from here? And here's where things become complicated, because we do need to have, for all humans, cross-cultural, cross-species, complete and balanced diets, which have to be all of these things at once. Good tasting, affordable, culturally appropriate, low impact on the environment, and of course, as I said, nutrient-rich. So how do we do that? So there is some interesting work that now is trying to link nutrition with the environment. So some of the issues about urbanization, sustainability are exactly the same in public health. In fact, increasingly, sustainability concerns are addressed by national dietary guidelines. In some countries, notoriously not in the US, but in other countries, yes. And we're going from my plate to my sustainable plate. And here I just want to finish off with this definition of sustainable diets from the Food and Agriculture Organization of the United Nations. This sentence seems to have been written by a committee or multiple committees, because they talk about just everything. Diets with low environmental impact contribute to food and nutrition security and healthy life for present and the future. And they talk about biodiversity, ecosystems, culturally accessible, appropriate, and so on. But there's one important component. Very often people think that sustainability means exclusively environmental impact, low environmental impact. The FAO definition makes it clear, no. Nutrition and health are a key component of sustainable diet. So diets have to be healthy, complete, nutritious, and with low environmental impact. And so the 4 components of sustainability will be the nutrition component, environment component, economics, and society. So I dealt with the nutrition component, I dealt with the economics component, the environment and society are kind of left alone, but these are the major issues in sustainability, because on one hand, climate change can affect what we eat tomorrow. On the other hand, what we eat today can have an impact on climate change. So it's a bit of a revolving door. What we eat now can affect future weather, and catastrophic weather events will determine whether or not we have anything to eat in the future. And hence, the search for alternative protein sources, because the current protein sources from seafood and beef, and to a lesser extent dairy, may not be sustainable in the long term. So the question is what to do. So remember, food sustainability has 4 domains, not just the environment. There is nutrition, environment, society, and economics. And we need to be thinking in terms of all of those components for the future. So the sustainable diets need to be complete, balanced, nutritionally adequate, culturally acceptable, and also planet-friendly. And complicating it all is, of course, climate change. And now we're increasingly talking about the food system resilience to climate change. So sustainability includes nutritional value. Remember that. And we go back to nutrient profiling, nutrient density, and complete and balanced diets. Thank you.